What's poppin', dogs? Mr. Allen here, about to graph a quartic polynomial in this video, but we got a bit of work to do before we get over to this graph because I'm given the function in standard form. And the only good part about standard form polynomials is, well, I can see if it's a positive or a negative quartic function, and I do get my y-intercept of 0, because everything's 0, comma 50. So I guess that's nice, right? Let's plot it. Let's get a head start here. 0, comma 50. So I guess I lied. We are over here already, but what else? Okay, well, I'm given x equals -2 and x equals -5 are zeros of this function. It's asking me to write the polynomial as a product of linear factors and graph it using the x and y intercepts. Well, we got the y-intercepts, so we're ahead of the game here. But how do I deal with this? Okay, now if I had a calculator, I could plug it in. I could find my my x-intercepts and all that. But generally speaking, these are going to be in a non-calculator section. Okay, if the numbers get a little too crazy, I might bust that bad boy out. But I'm going to show you basically how to do this without a calculator. And what I need to do is I need to divide out my factors of x plus 2 and x plus 5 from this polynomial. And the easiest way to do that is with synthetic division. Okay, so we're going to start with doing a little synthetic division. And it does not matter which one of these two you pick. Okay, the math will look a little bit different along the way, but you should still get to the same result that I do, even if you started with a different one. So I'm going to put -2 in the box here. And everybody writes up synthetic division a little differently. I was taught like this. And then I put all my coefficients. So we got 2, we got 21, 74, 105, and 50. Let's double check. 2, 21, 74, 105, 50. Cool. All right. And then I draw a line. I see some people do like this kind of a thing. I don't really care. It doesn't matter what you do. Either way, drop it like it's hot. Drop the 2. -2 times 2 is -4. And then I have 21 times plus -4. 21 plus -4 is what, 17? So we got -2 times 17 is -34. Okay, we're doing all right. This guy here, 74, -34, that's 40. -2 times 40 is -80. That gives me positive 25 when I add them. -2 times 25 is -50. Beautiful. And I get 0. Now, the nice thing about these is if I tell you these are zeros, and you do your synthetic division and you don't get 0, I did something wrong. You know you did something wrong at that point. So my remainder is 0. Lovely. Now what we're going to do is synthetic division all over again with those numbers. Okay? And then this time -5 goes in the box. So I'm just starting over again, but we're going to drop this guy, 2. -5 times 2 is -10. 17 and -10 gives me positive 7. That gives me -35. That adds together to become 5. -5 times 5 is -25. Oh my goodness, it's all working out wonderfully. So I'm left with that right there. But what is that, right? Well, I just divided a quartic function, okay, degree of 4. I divided it by a linear factor that was x plus 2 and another linear factor that was x plus 5. Those are the x values that when it equals 0, that's the 0, right? But I divided it by a linear by a linear. If I divide by a linear twice, I'm left with a degree of 2. This is a quadratic. Okay? And you can also see that by just going backwards. This is my remainder, my constant, my x squared. But it's also good to think about that, like, what's actually happening here, guys? Well, I'm dividing by 2 linears, thus leaving me with 2 degrees lower than 4, a quadratic. So I have 2x squared plus 7x plus 5. Well, what can I do with that to find my other factors, my other zeros? Well, I'd have to set that equal to 0, and I'm going to factor it and solve. If it is factorable. Hopefully it is. Well, let's see here. Does anything multiply to 10? 2 times 5, it's 10. And add to 7? Yeah, it's 2 and 5. So I know it's factorable, and I like to go guess and check style here. So these two numbers need to multiply to 5, while this times this and this times this added together gives me 7x. So if I did 5 over here, I'd get 2 times 5 is 10. That's not going to work out. So let's throw the 5 right here and the 1 right here. They're both going to be positive. Everything's positive here, so that takes some of the guesswork out. But let's double check it. 2x times 1 is 2x. 5 times x is 5x. 2x, 5x, 7x. Woo woo, America. Now I can set these equal to 0. 2x plus 5 equals 0. That's going to be x equals -5 halves, or -2.5. And over here, x plus 1 equals 0. Well, that's just going to be x equals -1. All right. So we have all of our zeros now, don't we? We got -2. I have -5. 1, 2, 3, 4, 5. We have negative, that's 2.5, so negative 2.5 is right here. and I have -1 right here. All right, everything's on that side. Well, this is a positive quartic, we said, right? So that's going to be like a W shape. And I like to maybe sometimes just like, okay, I know the graph's going to look like this, right? There's nothing bouncing, so it's just going to kind of go through. And then my y-axis is going to be somewhere over there. So I like to do a little rough sketch at times. So I'm like, okay, how's this going to look? Okay, I got a general idea. Sometimes I'll even go through like a little practice round, like whoosh, 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 whoosh. Sound effects, most definitely necessary. And now I'm ready to rock and roll, hopefully. Hopefully I don't screw it up. I like to, okay, I think I know what I'm doing. Come up, not too high, not too low. Shoot for that Y. Whoa, I got a little wonky there. But overall, pretty darn solid. I feel like I could have done better right there. Oh, well. I feel like man, I'm a little upset with myself. Let's do this. This will make it all better. There's my Y-intercept. All right, we're good to go. And then pop an arrow over here, of course, as well. So that's all good, right? Again, I'm being a little too nitpicky on myself here, but something like that. All right. So we've got our lovely quartic function with our giant y-intercept. Someone might get mad at you for that. Don't make your y-intercept that big. Erase it with your pencil. These markers are a little tough to erase. Okay. So let's make sure that we've got everything, because I think we're missing something here. Given these zeros of the function, f of x, that, right, the polynomial is a product of linear factors, and graph using the x and y intercepts. We graphed it using our x and giant y-intercept. Now we got to write it as a product of linear factors. So I would have f of x equals, well, I've got two of the factors here, 2x plus 5, x plus 1. But what are my other factors? Well, we said this one, the factor would be x plus 2, because -2 would make that 0. And this one would be x plus 5. Now I have a product of linear factors for this function. Okay? So always make sure that you read the whole problem, make sure you answer everything. But that's a doozy, man. That's a lot. Double synthetic division, getting all your points lined up, not making a terrible y-intercept like I did, but overall, hopefully we got the point across. Again, no matter, you could do it either order here, it's just these numbers are going to look different until you get to the final result. The 2, 7, and 5 will be the same for the second one, no matter what. It's these that will be a little bit different right here, the 2, the 17, the 40, and the 25. If I started with -5 first, it'd be something different. Okay, so hope that helps you guys. I know polynomials, there's so much stuff we could do with these. This is just one fun little problem, right? Fun problem. So if you have any questions or requests for videos or whatever, pop it in the comments. Happy to make them if I don't already have them. And have a wonderful day. Thanks for watching.